In this video, we're going to take a look at creating advanced triggers with the test editor. Now, if you've worked with trace validation files in the test editor, advanced triggers are similar, albeit they have far fewer things that you can look at and there's far less going on, but they're a very similar concept. So to get started, we'll just go ahead and select Test Editor, then go down to New and select Advanced Trigger. When we do that, we'll get a very basic template file that'll open up, and then we can work from there. So to get started, let's just take a look at creating a very basic advanced trigger. And we'll just use the setup of this particular template to do so. So just like trace validation files, we have states and we have events. Now when you're working in advanced triggers, you'll see in the toolbox that you have an advanced trigger section and a trace validation section. You can go ahead and ignore anything in the trace validation section, as you won't need those for advanced triggers. So I'll expand the advanced triggers, and you'll see I have advanced trigger states and events, as well as a trigger, and then under general I have transitions and comments that I can add. Now, as I said, advanced triggers work very similarly to trace validators. You have a state, and a state is a spot in which things will just sort of wait, and they wait for something to happen. And the things that they're waiting for to happen are the items defined in your events. Once the item in the event happens and everything fires, you'll actually have a transition to another state. So in the basic template, we have an initial state, one event, and then a trigger. Once you reach the trigger in your advanced trigger, it will actually cause the trigger to fire in the instrument, and your memory will fill, and then the trace will unload. You'll also notice the initial state here has this mark that looks kind of like a target without a bullseye. That indicates that this is an initial state, and you can see that by clicking it and looking at the properties over here. States can be initial or normal, and then you'll notice that your trigger looks like a state, has this bullseye on it. There can only be one trigger state. If your trigger state gets deleted, you can re-add it by dragging trigger on from the advanced trigger section of your toolbox. In order to put the transition between this event and this trigger state, you select transition, you click the event, and then you click the trigger, and the transition is back. Okay. Now let's walk through an example of a very basic advanced trigger, and in fact this will be a one packet trigger, so it would be analogous to setting up a simple trigger in the application software. So I'll just go ahead and click the event, and you'll see it's currently set to ignore event. I can change this to any packet type I want, and I can change it to Unipro or a UFS packet by changing the packet type on the event. We're going to go ahead and work with a Unipro packet for this example. Packet name I can then drop down, and because I've selected Unipro as the packet type, you'll see I get a list of all the Unipro packets that are available. So in this case, let's just trigger on a power mode request. We want to see that the power mode has changed, and we want that to be the point in which we trigger. If I were to leave this alone and run this with my instrument, I would trigger as soon as I see a power mode request on sublink 0. Now you'll see a few other pieces of information on here. The packet matcher, which is set to 0, and the state matcher, which is set to none. You have these resources available inside the hardware, and they're only finite resources. So you can have so many packet matchers or so many state matchers, and when I have a packet matcher value here that is not -1, it means I'm utilizing one of my packet matcher resources. If I were to set up another event, either on this particular state or on another state that's exactly the same as this, a PACP power mode request, the packet matcher could be reused, and you would see it as also having a packet matcher of 0. But we'll get into that when we look at multiple states. You'll also see I have no state matchers. State matchers are a thing that allow you to trigger on certain types of event transitions, and we'll get into that here shortly as well. So you'll also notice on this event that I have other validators, counter validators, and field validators, and I have actions available. One type of validator that this is going to look at is the packet name. So it has to be a PAC power mode request. If I don't have any counter or field validators, then that's all it would look at. If I want to add some field validators, I can right click here and select Add New Field Validator, just like I can in a trace validation file. Or I can actually get the packet editor dialog that would be similar to what you'd see in the application software if you were to be editing a simple trigger and double click the packet. To do that, I'm just going to double click on this event, and up will come this packet editor window. And this one has a few fields, so it's a little big for my window, so I'll just size it down. And you can see here, I can see all the fields that are part of a PACP power request packet, and some of them are hard-coded because the PACP function ID of 020D is what a power mode request will have. So you can't change those. And everything else is basically set up to X, meaning you don't care about those values. So you're able to put things in here to see what happened in the packet, and you're able to further refine your trigger. So for example, if I only want to see that we're going into a gear of 3, I could come down to TX gear and make that a 3, and also I'll make RX gear a 3. So basically now I would be looking for a PAC power mode request packet that has TX gear and RX gear set to 3. Everything in here that's a validator essentially works as an AND. So in this case, it's this kind of packet with this and this set to 3. There's no OR logic within a single event like this. So I'll click OK, and you'll notice that my field validators are populated. So I could edit these later on if I want. And the other thing you'll notice, these values are displayed as binary strings. So this is a binary 0, 1, 1, or a value of 3. It also shows you that there are 3 possible bits in TX gear and RX gear, hence the 0, 1, 1. So you know the highest you could go here would be a 4, a 2, and a 1, or a 7. So that creates a field validator. We can also validate counters and use counters to count certain things, but we'll look at that when we look at a more advanced trigger that has several states. So on the surface, this is done, and I could run this on an instrument and see this trigger. So we'll go ahead and do that, but before I do, I just want to make one other change. Rather than trigger on sublink 0, I'm going to go ahead and set this up to trigger on either. So if I see a power mode request either on sublink 0 or sublink 1, my trigger will go ahead and fire. So first off, I'll just do a save as. By default, the save location is your advanced trigger folder, and this is where the application software will look for this advanced trigger. So we'll just go ahead and type a name for this particular trigger as power mode request, and go ahead and click save. So here we are in the application software, and I'm just going to go ahead and connect to hardware, and we're going to take a look at the trigger dialog. So you can get to that by clicking the little T up here next to the settings and the analyzer connect button, or by clicking tools trigger. Now once the dialog comes up, you'll see in the upper left hand corner you can choose the type of trigger you want. Your options here are no trigger, trigger immediate, use simple, or use advanced. In this case, we're going to take a look at that advanced trigger we just created. So I'll select use advanced trigger. On the left hand side, you can see all the triggers that the application loaded from the advanced trigger folder, and you'll see we have our power mode request trigger. So to actually program the trigger, I either have to double click it or drag it over here to the right. Simply selecting it will not cause that trigger to become active. And you can see that even though I've selected power mode request, the trigger currently loaded is this AFC TC0. So I'll go ahead and drag our power mode request over to the right. And now we've effectively loaded that trigger, and when we click OK or apply, it will go ahead and it'll program that trigger into the hardware. You'll see I get a very basic sort of layout of what the trigger looks like, and this should basically match what we saw in the trigger editor. You'll see that we're looking for either direction, packet equals PACP power mode request, and if I double click on the PACP power mode request packet, you'll see TX gear and RX gear are both set to 3, which is what we did in the editor. So I'll just go ahead and close that out, and I'll click OK. That trigger is now programmed into our analyzer. So I'll go ahead and start the analyzer, And now I want to run something that's going to cause this trigger to fire. And you'll see over on our instrument status pane that our trigger status has gone to waiting for advanced trigger. So it's waiting for our advanced trigger to actually meet its requirements and fire. So because we're looking for something with a gear of 3, I'll pick HS gear 3, and I'll scroll down and pick a very basic stim test. I'll just pick from the Unipro CTS test cases 112 direct access to the M5 module attributes. I'll go ahead and click reboot or boot, and you'll see I'm still waiting, and then I'll click on start stim. Now after a second you'll see that my trigger status has gone to triggered and filling memory. Now typically with a trigger this will continue to capture until my memory is full, at which point it will unload. But I'm not going to put any more traffic over the line right now, so I'll just go ahead and click stop. Now once my trace unloads, and I'll just scoot this up so you can see a little bit more, you'll notice that I have a bookmark way down here at the bottom called trigger. That bookmark tells me where in my trace the trigger actually fired, so I know where to look. I can get to that by either right-clicking and selecting Go to Trigger, or by double-clicking the trigger bookmark in the bookmark pane. You'll see that takes me down to this packet, which happens to be at 687. It's a PACP power mode request, and if we look at the packet breakdown, TX gear and RX gear are both 3. If we look at the traffic overview for this particular capture, you'll see that there were 27 PACP power mode requests. All 27 occurred after this one. So if I were to go to the very next one, I would see that it's just a power mode request. The trigger's not here because the trigger fired on the very first instance of PACP power mode request with TX and RX gear both set to 3. Now I could have done this with a simple trigger, just going into my trigger dialog, selecting simple trigger, and picking a power mode request, and picking the TX mode and RX mode, and having this simple trigger go. But we wanted to use the advanced trigger, and the advanced trigger can do so much more than a simple trigger, and it's all about looking ahead and using multiple states in order to see that things are occurring in an order in which you're expecting. So we're going to switch back to the editor and make a slightly more advanced trigger. So here we are back in the editor. What we want to do is take this to the next level and look for the other side of a power mode request, for example, to make sure that we're seeing a full power mode request with a conf involved. So what I'll do is drag this advanced trigger state just kind of up and to the left to make some room, and I'm going to rename it so it sort of gives me a reference. This doesn't have any bearing on the trigger itself, it's just so you can keep things straight. So I'll call this wait for request. And this state will wait for a power mode request. Now instead of transitioning to the trigger, I'm going to break this particular transition by clicking it and then pressing the delete key. I want to move to another state that then waits for the conf. So I'll drag on a new advanced trigger state. I'll double click it and I'll call this wait for conf. Once I see my power mode request, I want to transition to this wait for conf state. So I'll drag a transition and I'll click power mode request and I'll click wait for conf, and there's my transition. I'm just going to zoom this out a little bit, and I'm going to move my trigger state kind of down to the right. And I'm going to click this note that we put in our template. This is a comment box, and just delete it to free up some space. So to my wait for conf, I need another event that does something and waits for something else. So I will do an advanced trigger event. So I'll drag that onto my wait for conf state. Now you'll notice I had to drag this event onto a state. If I try to drag it onto another event or onto the work surface itself, you'll see I have that circle slash symbol, meaning I can't drop it there. Events have to be associated with states, so you have to drop it onto a state. So what we'll do is set this one up to not ignore an event, but instead to look for a PACP power mode conf. And we want this to set up to where we look in one direction for the power mode request and the other direction for the conf. So I'll go back to my power mode request, and I'll change this either to look for a request from sublink 1. And we'll go ahead, and now our conf will look on sublink 0. So we'll look for a request on sublink 1 and a conf on sublink 0. We're not looking for anything particular on this power mode conf as far as fields, but you could double click it and set up field values to further refine what you're looking for. We're just going to leave it alone and look for a power mode conf. That's just fine. So you'll notice a couple things. One, this is using a packet matcher of 0. This is using a packet matcher of 1. So we are using two different packet matchers because we're looking for two different packets in two different sublinks. Now once I see this power mode conf, I want to trigger. So I'll drag my transition from my power mode conf down to my trigger state. And now we've made a two-state advanced trigger. This is something you cannot do with a simple trigger, and it will only trigger if I see a power mode request on sublink 1 followed by a power mode conf on sublink 0. So let's go ahead and save this, and we'll take a look at how it works in the application software. So back at the application software, we'll just go back into our trigger dialog, and you will see now that our power mode request has been refreshed because it's been saved off into that same folder with the same name. And you'll see we have the same similar breakdown. Here's the state that waits for a sublink 1 power mode request, followed by the state that waits for a sublink 0 power mode conf. So the trigger's been updated in our app. I'll just click OK to make sure it's programmed properly to the hardware. And we'll do the same thing we did last time. We'll start the analyzer. We have PWM Gear 1 and HS Gear 3 selected, and we're going to run the 112 Unipro CTS stim. So I'll just click Start Stim. You'll see I have now triggered and gone into fulfilling memory state. So we'll hit stop. And you'll see now that our trigger bookmark happened very early. It happened on packet 8. But it didn't trigger on the power mode request. This time the trigger didn't happen until we saw the power mode conf. But if I select the request, you'll see very clearly it was for a TX gear and an RX gear of 3. And then the power mode conf came in and the trigger fired on it. So that was a very quick example of how you can do an advanced trigger using multiple states. Now there's a few other features of advanced trigger that I want to cover. These are some of the more advanced features of building an advanced trigger. So we'll switch back over to the editor, and what we want to do is look at counters. Counters are another resource available to us that can help us look for some number of some things to happen prior to this trigger kicking off. So in this case, let's try to find more than one power mode request conf sequence. So first of all, I want to make sure that my counters are set up to be utilized and count some number of resources. To do that, I can right-click the project surface and select Manage Variables, or I can come over to the State Machine Properties and select Manage Variables. Counters are stored as variables inside the editor. You'll see in some older versions you might see a counter list. Ignore those, and if you actually try to click on them, you'll get a dialog that says they're not available for advanced triggers. So we're going to go into our Manage Variables window, and you'll see in here I have two variables set up, one called counter 0 and one called counter 1. I cannot rename these, I cannot delete these. These are the two counter resources that I have available in my advanced trigger. You have to tell it when you want this comparison to basically be true or false against some value. And so you can see I can have a comparison of equal, greater than, less than, or greater than or equal to. I'm going to select equal and say my target value is 5. So all that's saying is later on in my advanced trigger I can look to see if this counter has met its target comparison. So in this case that target comparison is equal to 5. So I'll click Done, and after this PACP power mode conf, I'm just going to compact this a little. I'll drag some states under one another so we have a little bit more room. So after this PACP power mode conf, I don't necessarily want to trigger. So I'm going to delete this transition. Again, I click it and press delete. What I want to do is see if I've reached 5 power mode request power mode conf cycles. So the first thing I need to do is count them. So to do that, I'm going to right-click Counter Actions and select Add New Counter Action. And in here, I'm going to select the variable counter 0 and apply ++ as the action, which will increase the value by 1. So it starts as 0, it will then go to 1, and then 2, and so on. Now, you'll see I can also reset that, meaning go back to 0, or I can do a -, meaning I need to go down in the count. In this case, we're going to count upward. Off this wait for conf, basically what I want to do is I want to move to another state that says, hey, has my counter reached what I expect? So I'll drag a new advanced trigger state on. I'll transition from my PACP power mode conf, and I'll add a new advanced trigger event. Now I want to name this state check count, because that's all I want this to do. I want this to check the count of my PACP power modes and trigger if I'm where I expect to be. So in this case, I'm going to ignore the event. I don't want to look at the packet at all. All I want to look at is the counter. So I'm going to right click and add a new counter validator. You'll see that it'll say set the validator compare in properties. So I'll come over to this properties window and I will look at the variable counter 0, and the condition I want to check for is true. Has it reached its target value? And in the variable window, remember, we set this to say counter 0 equals 5. Now when I click out of this properties dialog and go back to the event, you'll see it actually gives me a little more information, so I don't have to go look at my variables window again to see what this is set to. And you'll see that the validator says counter 0 is equal to 5 is true, meaning we are equal to 5. I could say is false, and then if counter 0 was anything except 5, it would also then trigger. So what I want to do is, if this is the case, counter 0 is equal to 5, then I want to trigger. So I'll transition from this to this. Now, if it's not equal to 5, I want to go back to the beginning and wait for more power mode requests. So to do that, I'll just drag my trigger event down to the bottom, and I'm going to move this check event down and move this state down, because we're going to add another event to this state. So I'll drag on another advanced trigger event. I'll just put it above it, and I want another counter validator. But in this case, I want to see that counter 0 is false, meaning it's not yet equal to 5. If that's the case, then I want to transition from this check count state back to wait for another power mode request state. And you'll see my lines are starting to crisscross a little, so I'll just pull that down so you can see the flow a little better. And so now this particular advanced trigger will wait for a power mode request from sublink 1, then wait for the comp from sublink 0. Increment the counter saying it's seen that cycle, and then it'll check. If we equal 5, we'll trigger. If we don't, we go back and wait for another power mode request. So let's save this and see how it works in the application software. So back in the software, let's go look at our trigger edit dialog, and you'll see we now have 3 states in our overview: our wait for request, wait for conf, and then check our counters. So we'll click OK to make sure that's programmed, and we're going to run the exact same stimulus. You'll notice that in the last one we got 27 power mode requests, so that should be plenty to go ahead and trigger our advanced trigger. So I'll go ahead and start the analyzer. We will start the stim, and you'll notice I've gone to triggered and filling memory once again. So we'll just hit stop. So here's our data. I'll double click our trigger bookmark to go down and find our power mode, and you'll see here's our PACP power mode request, gear 3, and here's our conf. Now how do we know this was the 5th one? Well, if I select my PACP power mode request and I go into our traffic overview and select PACP power mode request, you'll notice this is the 6th one in the file. So at least 5 have gone by. And remember, we were only counting them where the TX gear and the RX gear was 3. So presumably one of these first 6 was a power mode change to a different gear, probably PWM gear 1. And so that one didn't count. But this is in fact our 5th power mode request that matched our advanced trigger state and the 5th comp that followed. So that's when our trigger fired off. So flipping back over to the editor, there's a couple other things that I want to look at in the advanced trigger. Specifically, I want to look at state matchers. State matchers allow you to look at certain unipro states in a single resource rather than chewing up packet matcher resources. So for example, if I wanted to look for a capture that has gone into hibernate, I could go set up a power mode request and look at the correct fields to see that we're seeing a power mode request where it's requesting hibernate. Or I could look for the link state. And you'll notice, so we'll just pick any one of these for now, you'll notice I could select hibernate as the packet type. And you'll see that that uses a packet matcher resource. And let's just put this back to PACP power mode request. Alternatively, rather than using a packet matcher resource, I can use a state matcher. Now, state matchers have to be pre-configured before they can be utilized. So I can right-click and I can say Manage State Matchers. And I get the State Matcher Manager dialog. And you'll see that right now I have no state matchers configured. So I'll go ahead and click the Add button, and I can give this state matcher a name. And I'm just going to call it Hibernate. And click OK. Now from here I can select which states I want this matcher to look for. And in a state matcher, this becomes OR logic. So I can say this state matcher is looking for Hibernate, or line reset, or sleep stall, or whatever I want to do. So in this case, what I'll actually do is have it look for both Hibernate and sleep stall. And I can configure whether I want this state matcher to run on sublink 0, sublink 1, or either. Now you only get 4 state matchers, 2 per direction, available in your advanced trigger. So if I select either on this state matcher, that means it's going to use up 2 of your state matcher resources, both a sublink 0 and a sublink 1 state matcher. And the editor should throw errors and warnings if you attempt to exceed that limit, so you don't have to necessarily worry about how many are allowed. The app will stop you when you've reached your limit. So I've set up my Hibernate state matcher to look for either Hibernate or sleep stall, and I'll just click Done. Now that just configures it. I actually have to put that to use somewhere in my trigger. So what I want to do is I want to say that we're still checking this counter. I want to have seen at least 5 power mode requests, and then I want to see a Hibernate before I trigger. So I'm going to make a change to this counter. So I'll right click, Manage Variables, and in this case, rather than counter 0 being equal to 5, I want it to be greater than or equal to 5. Meaning if it's 5 or higher, we're allowed to trigger. And I'll click Done. But in order to trigger, I want this to be 5 or higher, and I want to see that we're matching that state matcher. So I click the event, and you'll see under matchers I can drop down my state matcher and pick my Hibernate state matcher. So now this will look for counter greater than or equal to 5, and I'm seeing my Hibernate state. If I'm not greater than to equal or equal to 5, I'm going to go ahead and loop back around. So now what should start happening is once I reach this check count, if my counter is greater than or equal to 5, this will no longer fire, so I'll stop looping back. But I'll wait in this check count state until I then see a Hibernate that occurred after my counter reached that 5 level. Okay? So now I'll wait in this event until my Hibernate state matcher is true and my counter is greater than or equal to 5. So until I see a Hibernate or a sleep stall with a counter over 5, I'll start waiting in this event. While my counter is under 5, I'll be looping and counting power mode requests and confs. So I'll go ahead and save this trigger. We'll switch back into the application software. We'll go take a look at our advanced trigger dialog, and you'll notice that we have the same sort of setup where we're waiting for different counters. This doesn't show state matchers at the moment. That should be coming shortly, but we still have the same 3 states. So I'll click OK. I will go ahead and start the analyzer, start that same stem where we're running in gear 1 and gear 3, stem 112, and again you'll see I've triggered and I'm filling memory. So we'll go ahead and hit stop. So now you'll see if I come down and double click our trigger that it went ahead and triggered on this Hibernate event following this power mode conf, which presumably was our 5th power mode conf that we saw in the trace. So that's an example of sort of combining packet matchers with state matchers and counters in order to go ahead and look for multiple different possible things that have now fired in your trace. Next, we want to look at creating an advanced trigger that looks at both UniPro and UFS packets. This is really simple. There's nothing special about setting this up. You just have to change the packet types and you're allowed to mix and match them. Unlike trace validation files where everything has to be UniPro or UFS, with advanced triggers you can actually mix and match within the separate events. So we're going to work from the same example we've been using, but we're going to go ahead and take this check for the count out, and so just delete these events. And instead, what I want to see is a power mode request changing to HS, or changing to a gear 3, which is what we've done here throughout this example, and then the conf. But then I want to see some sort of unipro frame. So I want to check for UFS data. Okay? And so we'll move into a check for UFS data state, and we'll add an advanced trigger event. Now, when it comes on, you'll see the default is Unipro. But if I just select it and go over to the properties, I can change it from Unipro to UFS. And now I can set up UFS data. And so I could come in here and say, look for a query, or actually we'll just say, look for any data in packet. So that will look for either query request data in, query response data in, any of the possible data in packets. If you want to look for a very specific one, you can actually come down and look for query response data. You can look for task management data, but data in allows me to look for any data in packet that happens to exist. So I'll just set that up. I will say it can be on either sublink. And from there, I will leave everything else defaulted. And once I see then a data in, I want to trigger. So we'll go ahead and move our transition point down to the trigger. So now I'll look for a power mode request. I don't care about the counter, so I'm going to delete this counter action. So I want to have seen a power mode request with TX and ARCS gear at 3, a power mode conf, and then I just want to see a data in packet in either direction. And once that happens, I want to trigger. So let's save this. So we'll switch back over to the application software, and let's just check out our trigger dialog. And now again, you can see our power mode request has a power mode request and a conf, followed by UFS data in. So we'll hit OK, make sure that's programmed. We'll switch over to UFS so that we can see some UFS test cases. And keep in mind that when you're using advanced triggers that have UFS and Unipro data, you need to be in UFS mode in order for them to show up in the application under the trace validation section, but it does not matter for the trigger as long as you're getting UFS and Unipro data. The test we're going to run is 7.12.2 or UFS read 602. So I'll select that stem. If you haven't already, you'll need to make sure you have a LUN configured, and so here I have LUN 0. And we'll just start our analyzer, and we'll start our stem. And you'll see once again we've gone to triggered and filling memory. So I'll click stop, and you'll notice on our Unipro side I do have a trigger. And if I double click it, you'll see it's on this data frame down here. Well, data frames are how you encapsulate UFS data. So if I go over to my UFS packet list, I should see that trigger is on, in this case, a read capacity 10 response data in. So it was the first data in packet that I encountered in UFS after seeing my power mode changes occur in the Unipro side. And you can find those by looking at your traffic overview, power mode request, and if I go back to that second request, you'll see here's the request, TX and RX gear R3. Those occurred as part of our advanced trigger, and then we were able to reach this trigger state, the first data in packet. So that's a very simple example of how you mix Unipro and UFS. And if I flip back to the editor here, you'll see it was literally just as simple as changing the packet type on this event from Unipro to UFS. So this advanced trigger can look at both sides. Now there's a couple other little areas we did not touch on in this particular example, and they are log message actions and they are external triggers. Log message actions have nothing to do with advanced triggers. They allow you to log messages to the application if you want to test your advanced trigger. Now what do I mean by that? All of our advanced triggers will also write out as trace validation files, so you can test them out with offline data with a captured trace. Now if you're using a combined Unipro UFS advanced trigger, it won't work correctly in trace validation because trace validation has to be either Unipro or UFS and not both. But if you're using one that's one protocol or the other, you can test it offline. And I'll show you real quick what I mean. I'll add a new log message and we'll just make this an info message. Text, we can say conf scene, and that now is a log message action that'll show up on screen. Now because this doesn't work if you have both Unipro and UFS, I'm going to get rid of this check for UFS data, and I'll just put a simple transition back on here from the conf to the trigger. So now this just looks for a single request and conf and then triggers. But what we want to see is the trace validation portion of this. So I'll save this and we'll switch back over to the application software. Now you have a very special folder down in your test list, and I'll flip back to Unipro because this was all Unipro, and it's basically going to be called Advanced Trigger Offline. Now you might see a bunch of other folders depending on what you have in your custom tests, as I do here, but under Advanced Trigger Offline you'll see we have our power mode request trigger. So I'm going to go ahead and select this and hit Start TV, and what this is going to do is run against this offline data I have. And you'll see here that rather than going through live hardware, it actually ran through, and here is my test ID saying, oh, this was a power mode request and the rule is triggered, meaning this is where this would have triggered had I run this on live hardware. So it's just a way to test your advanced trigger against offline data. And you can run this against previous captures, or you can run this against live data that you just captured. It doesn't really matter, but it gives you a way of kind of testing your advanced trigger offline if you're making some tweaks prior to running it against live hardware. It's also a great way to look and see why maybe your advanced trigger didn't fire when you expected it to, because you now have the offline version against some trace data that you had just captured. Now really the only other thing that we haven't looked at is the external trigger, and it's just another validator inside your events. So if you click on this event that was looking at my PACP power mode conf on sublink 0, you can see the other thing I can set over here is validate trigger in, and that's defaulted to ignore, or I can set it to low or high. So if I'm using an external trigger and I've connected that trigger in on the actual instrument, if that trigger is low, I can add that as part of my validation here. Or if that trigger is high, I can add that as my validation here. Meaning this event would only now trigger if I saw a PACP power mode conf on sublink 0 and the trigger in was high. Okay, so that's just another thing that you can check, and it's over here available in event properties. So I'll set that back to ignore. So with that, you've seen all the components that are available in Advanced Trigger. We created a few basic advanced triggers, 2 and 3 state advanced triggers, but they can get as complicated as you need them to be. They could have 3, 4, 5 states, and they could trigger on various different things and loop back on each other. And you're only limited by the resources available in the hardware. Those limitations can be found in the user manual, and this builder won't allow you to exceed those limitations. So for example, I'll just drag on a 3rd advanced trigger state, not a problem. A 4th advanced trigger state, not a problem. And if I attempt to drag on a 5th advanced trigger state, you'll see I get the circle with the slash through it. So the editor itself will keep you in check as far as all of your resources go. So you shouldn't be able to create an advanced trigger that would use more resources than you have available. So hopefully this gives you enough to start setting up some advanced triggers, and you have the confidence needed to go ahead and run them in the application software against some live data.